I'll be going over my paper prediction of wine quality using the multiple linear model. And these next two slides are just the agenda for we're going to go over in this paper. So first we're going to start with a little bit about me. I'm a senior at the University of Nevada, Las Vegas currently, and my major is in economics. I plan to graduate in May of 2023, and currently I'm a cashier at a nightclub, but after graduating, my goal is to start a career as a data analyst, and eventually I would like to go back for my master's in about 2 years. So for this paper, the main question is, with a certain quality of wine, is there consistencies in physical qualities across those with similar quality levels? So for example, if an expert were to rate a wine at a higher level, will it have the same characteristics about it, like citrus acid, the amount of alcohol in it, or residual sugars? Will it have any of those characteristics in common with another wine that was also rated as a high quality wine? And also something important to keep in mind with this paper is what determines wine quality. For the most part, it is smell, taste, the way it looks, and keeping in line with what the wine is supposed to be. So for literature review, I just wanted to start with a paper that generally uses multiple linear regression. So multiple linear regression is mostly used to evaluate correlation between multiple variables and one dependent variable. The assumptions of this model are normality, linearity, no extreme values, and no multiple ties between independent variables. When looking for data sets on wine, this was a major component, the no multiple ties, as some had pretty repetitive variables where they would include density, though density was directly a result of alcohol and residual sugar, which you'll see are included in this model. So some data sets just did not work as well with the goal of multiple linear regressions. That was something to keep in mind as I was working on this. And I also included what the equation will generally look like. There's a dependent variable, the constant, and then however many independent variables. Then there was a paper that was extremely similar to the goal of this one. There's a black tea that they're focusing on in this study, and it ranges widely in price and value dependent on its quality. It can range from a few dozen to several $100s per kilogram, and it can be a time-consuming process for the experts on this tea to evaluate it. And then in this paper, they successfully created a model to take a more objective stance on quality when testing this specific tea. So right here I have the model of the expected signs and the definition of the variables. So starting with fixed acidity, I expected this to be positive. So this one was important to fermentation, and then volatile acidity I put that one as negative because it can add an unpleasant taste. Citric acid is expected to have a positive effect as it adds freshness and flavor. Residual sugar is expected to have a positive effect as all wines are sweet to an extent as it's made with fruit. Though there is this component of some are meant to be drier and less sweet and some are meant to be more sweet, and it includes the line at 45 grams. More than that's considered sweet, less is considered dry. Colorides, with too much present, it will start to affect taste, and intention is really important in wines, so that was expected to be negative. Next is free sulfur dioxide. So this one is important to preserve the wine and keep the wine fresh, so that's going to have a positive sign. And then total sulfur dioxide will have a negative effect. That can negatively impact taste. And so what wasn't detected previously will now be a bit overwhelming. pH will have a positive sign, though this won't have any major effects as expected because there is only a range between 3 and 4 on the pH scale, though each is on a power of 10, so it could change the wine a bit. Sulfates are next. That adds an antimicrobial and antioxidant agent that's expected to have a positive sign. Antioxidants are really important in wine. It's something that people talk about a lot, and antimicrobial is important with the fermentation process. Alcohol is expected to have a positive sign. The alcohol normally ranges between 5 and 15%, and more alcohol, and it's all about balance with wine. So with more alcohol and keeping it in balance will have a really positive effect on quality. Descriptive statistics. So this is all of the variables, and so some notable variables were free and total sulfur dioxide. These two variables varied widely, and the mean was on the lower end. So this doesn't necessarily mean that there was like a lot of extreme values. I think it more so explains why these can have such a negative effect. In some wines, it can get to higher values, and that will either lead to like the wine being of higher quality or lower quality. Alcohol, there was not too many on the lower range. Most of it stayed between 8 and 14.9%, and the mean was right there in the middle. The rest of the highly correlated variables, which we'll talk about later, they're going to be chlorides and volatile acidity. Those were both also mostly evenly distributed, and there wasn't too much of a difference between the minimum and the maximum. And then, this was the correlation matrix I was talking about. So the most correlated was alcohol, chlorides, and volatile acidity. Alcohol is expected to have a mild positive effect, correlation with quality, and then chlorides and volatile acidity are expected to have a weak but negative relationship to quality. As talked about earlier, those majorly affect taste, and then alcohol really helps with the balance, so that's why it's expected to have a positive correlation. Here's the scatter plots. The first one is alcohol and quality. There's that mild positive relationship, and the next two are chlorides and then volatile acidity. Both of those, we can see the weak negative relationship between those variables. Confirms what we saw in the correlation matrix. And then finally, we have some of the empirical results. So most of the variables had high statistical significance, specifically alcohol, sulfates, total sulfur dioxide, free sulfur dioxide, residual sugar, and volatile acidity. Those were at the highest significance level. pH and chlorides were also still statistically significant, but at a lower level. There were two variables that didn't have any statistical significance at all: citric acid and fixed acidity. It could be because there wasn't enough to say. It could be that it just had a milder effect on these wines. But as we get into the conclusion, I think that the model would be more accurate, adding differences to red and white wine and extending to specific types of wine. There are some wines where residual sugar is more important, or citric acid can be more important to the final product. But overall, some aspects of quality can be detected through the physical characteristics of wine, and this model could be the start to a more objective process of rating the quality of a wine. And here are the references. It includes the paper that he used to talk about wine quality, and then the two papers discussed in the literature review. Thank you.